Hello, let me introduce myself. I'm Steve and I'm the physics teacher at Wilberforce Sixth Form College, and I will take the opportunity to go through the basics of A-level physics at Wilberforce College. A-level physics is made up of 6 units which are covered over 2 years. Unit 2 is the basics of physics, which looks at all of the key ideas that is needed to understand it. It's a very small unit, and it basically goes through the very foundation skills that you need to be able to do the subject. The first year consists of 2 units, forces and motion, which looks at Newtonian mechanics and looks at how objects move, initially without no cause, but then focusing on forces and dynamics and explaining why objects do move. It's normally limited to 1 dimension, although projectiles is introduced at this point. And we then look at basic materials and how objects behave under stress and the concept of momentum. After Christmas, we then go on to electrons, waves and photons. This is made up of 3 subsections. Electrons focuses on electricity. We look at the principles behind basic electricity and what electricity is, and we look at electrical circuits and how electrical circuits will work. Not as an engineer, although the actual practical side of it will look at that, but we focus on the basics behind it all. We then move on to waves, and we look at different types of waves. We look at wave-like behaviour, and we look at particularly sound and electromagnetic waves, along with using water waves as our basis behind the theory. And then finally we go on to photons, which looks at the 2 models we've used so far in section 4 and prove that under certain conditions they are incorrect, and we come up with the photoelectric effect. In the second year, we then go back to Newtonian mechanics and materials. So we do some work on ideal gases, and we do some work on states of matter, and then we go back to Newtonian mechanics, but this time under more complex forces. So we look at circular motion, we look at simple harmonic motion, and we look at gravitational fields. And then we do our first case study where we apply our knowledge of Newtonian mechanics to astrophysics. So we start off with the birth and death of stars, what the sun is going to do, what other stars are going to do, and then we go on to the Big Bang theory and evidence for it, Hubble expansion, and we ask the question, what will happen next? Unit 6 goes back and looks at a combination of different topics, focusing on particles. It initially starts with electrical fields. It goes into capacitance, magnetic fields and particle physics. We then study radioactivity and nuclear physics, and then we do our final case study, which is on medical physics. We look at how physics can be used to look inside the human body. It focuses on medical imaging without physically cutting open. So we look at X-rays, CT scans, ultrasound, endoscopy, gamma cameras, and that brings us to the end of the course. You will notice I've missed section 1, which is development of practical skills in physics. That's because throughout the 2 years we will be doing a number of practicals. You have to do 12 practicals, but we generally do about 16 or 17, and you have to use every single skill in a list. This is a pass or fail course for the practical skills, so as well as getting the A-level grade from A star to E, you will also get a pass in the practical skills as long as you do all of the skills required. So, why take A-level physics? Well, A-level physics is what's known as a facilitating subject. These are the courses that the top universities are looking for. And the sciences and further maths and foreign languages and history and geography are all of the facilitating subjects. And if you want to be aiming for the top universities, these are the subjects you should be doing. Get very good results in A-level physics, and we develop a huge set of other skills required, whether practical skills, problem solving skills, analytical skills, mathematical skills. And it really goes well with the other sciences, chemistry, biology, maths, geography, and lots of other subjects, but particularly it goes well with maths. The required grades, we need a 5 in physics or a double 5 in combined science. And you also need a 5 in maths, although a 6 in maths is advisable. Talking of maths, we also recommend that you do A-level maths to go with it. It's not compulsory, but what you would find is that lots of the key skills that you develop in maths, you will also develop in physics. It's not that you can't do it without doing A-level maths, because the maths required in A-level physics is about 95% GCSE, and the other 5% we will teach in a lesson is just the fluency with the skill of mathematics, which you need to practice, and in certain areas we will do them for 2 lessons in physics and then forget about them. But if you did A-level maths, it would constantly be practice and practice, and therefore you will start to excel at that. It is an absolute must if you want to do a degree in physics, but if you also want to do any form of engineering, you need physics, architecture, and of course astrophysics as well. It's really useful to go with maths, and medical courses will also always ask for some mathematical base course, so physics goes really well with those as well, along with dentistry as well. We have excellent specialist scientific laboratories designed to hold up to 20 students. They are the same spec as the universities, and they are just absolutely outstanding places. We had recently refurbed 3 years ago, and what happens is they are top range modern labs that you would get as if you went to a top university or went to work in a scientific field in industry. Students who do this course go on to many things. So often go into forms of engineering. BP is an example where we've had apprenticeships there, but the university degrees often go on to physics, astrophysics, engineering, architecture, Formula 1 automotive engineer, and medicine. In fact, one of our current students is working for a Formula team as one of the senior engineers. There are jobs, however, they just do not have to go on to degree level. We get jobs as forms engineers, education, NHS, or lab technicians as well. So, if you're interested and you found this fascinating, please go onto our website and click on the courses. We will find more information about the course. You can follow us on Twitter. We are very active on Twitter. But if you have any questions, just email me. My email address is there, sls@wilberforce.ac.uk, and I will get straight